So hi everyone, welcome to this uh, second part of SQL training. Okay. Now, again to get started, we will use the same set of tables that we had created earlier: customers, orders, payments, and returns. And then today in our scenario, so basically we will be looking at creating a data model using these four tables. Okay. Now let's start. Okay, so again we'll be using Azure Data Studio for this particular demo, and the database, as I said, I have created earlier, it will be the same Azure database. Okay, so you can use use a SQL database as well, but since I've used Azure database, I'll be using Azure database. Okay. Okay, so first let me create the connection. So we have created our connection. Let's go ahead and start. So basically, so in today's scenario, we'll be using these four tables: orders, customers, payments, and returns. And then we will be, in our scenario, basically, we'll try to create a data model, we'll be using orders as the fact table, and customers, payments, and returns operates as the dimension table. And this approach basically supports a lot of common analytics and reporting scenarios in e-commerce or any sales driven business. Okay. Now, what we have basically is in our model, we have this orders table. Then we have customers. Then we have payment. Okay. And finally, we have returns. Okay. So the four tables. Okay. Now, uh, regarding so let's take a look at our first use case. Okay. Now, if I want to find the total sales by each customer, okay, I can do that. So basically, I will be using select customer. Okay. Now, rather than using select star, what I'll be using, I'll be using select customer ID. Or I'll be using select customer ID. Okay. Let me first take a look at the column. So from customers, we just have ID. We don't have customer ID. So I'll just use ID. And then I'll use sum of sales. Sorry, we had to look at into orders table, my mistake. Select ID. So rather than using ID, I'll use customer ID and then sum of sales from orders. Okay. And since I've used sum, as we have been doing earlier, I will be using a group by. Okay. So let me structure it a bit. From orders, and then I use group by customer ID. Okay. So select customer ID, say sum of sales, and from orders and group by customer rate. So now if I go ahead and execute, oh, now the sales is basically sum of sales. So we will convert this using another function. We'll use cast. So basically the data type of sales is varchar. So what we will do, we'll use cast function to change it to decimal. Okay, as decimal. Okay, select customer ID from cast. Okay, so now if I go ahead and execute, so basically for each customer, I'm getting what is the total sales. Okay, so now what I'm getting, so again, I don't have an alias name, so I have to provide an alias name. So I'll call it as total sales. Execute. So basically customer ID for each customer, what is the total sales. So this way we can find out total sales for each customer. Then if I want to find out number of orders per customer, okay, if I want to get the number of orders per customer, okay, so rather than using sales, rather than using sum, I can use count. Okay, so I'll be using count of ID. Okay, from orders, then group by customer. So now if I execute, basically this gives me number of orders per customer. So you can see I can get the number of orders per customer. So if I want to add an alias name, I'll use as order count. Okay, so now if I execute, so customer ID and order count. Okay. Now, next, if I want to find a segmentation of customers based on sales, so basically, if I want to do that, I will be using two tables now. Okay. One is orders table and then is the customers table. So first I'll create a relationship between orders and customers. After creating the relationship, I will find the sum of sales on the basis of a certain segment. Okay. For each segment. Now, to do that, first I'll use select. Okay. Now, whenever I'm creating relationships, I can directly use the table name as it is. Okay. Sometimes what happens, there are some fields which will be available in both the tables. In that particular scenario, there will be an issue in terms of, sorry, there will be an issue in terms of from which table I'm trying to pull in. So that's why we normally use alias. So I'll be creating for customers. I'll create an alias name C dot. I'll use segment. Okay, and then from I'll use some orders. I'll use O as the orders name, and okay. So yeah, I was saying. So the next scenario is basically segmentation of customers based on sales. So we will create I'll bring segment from customers table and sales from orders table, and then I'll create a relationship between them, and then I will run the query. Okay. Now to do that, so basically what I have, select C dot segment, C representing the customer name. Then I'll also represent some from orders. I'll use sales, but I can't use sales directly, right? So I'll have to use sales using the cast function. So cast O dot sales as decimal. Okay. Now I'll use the table from where I need from orders. Okay. And then I'll create the relationship join. Okay. Now I want to create like an inner join. Okay. So customers C and orders have to provide the name as well. O. Okay. Join customers on. I have to provide what are the tables I need. O dot customer ID and C dot ID. Okay, because in customer table the customer ID is represented as ID, and in orders table it is customer ID. Okay, and next I will just go ahead and use group by C dot segment. Okay, now for this one I will use uh, an alias name total sales. Okay, so now if I go ahead and execute, so basically for different customer segments, this is my total sales. Okay, for consumer, this is the number, corporate and home office. So this way, basically, I can do a segmentation of customers on the basis of sales. Okay, now if I want to find out, sorry, if I want to find out top cities by sales, okay, what are my top cities on the basis of sales? I can also do that. Okay, I'll maintain the same relationship that I have between customers and orders. Okay, and next what I'll do, I'll basically use in my select statement, I will use uh, city. Okay, select city from customers, and then orders. I'll fill the relationship, and then I'll group by on city. I'll group by on city. Now, I want to find out my top cities. Okay, so to find out the top cities, I have to order it. Okay, order it in a certain structure so that the highest value goes on top and the lowest value goes on bottom. Okay, so to do that, so basically I have to use order by clause. Now, after using order by clause, so I'll use some. Okay, same function, solve the same calculation that we did earlier. Okay, sum of sales, and then I have to provide whether I want it as um, like what is the order, in which order I want. I want in ascending order, or else I want in descending order. So I have to do that. So I will use descending because I want the highest value to be on top. So I'll be using descending. Okay, so by default it will be ascending, but yes, if I'm using descending, so it will be like the highest value on top. Okay, so now if I go ahead and execute, so now you see, so now I'm getting the top sales. The city with the highest sales is New York City, and then LA, Philadelphia, Seattle. So as it goes along, it shows the values. Okay. Now, if I want to use top 5 customers by sales, I can also do that. If I want to use top 5 customers, there are multiple ways of doing it. In our last session, I did it in a certain way, but today I'll be doing it differently. So I will be using uh, limit 5. Okay, so let's see if limit 5 works in this. Yeah, limit 5 doesn't work, so it will work mostly in Snowflake if you're using. So I'll be using top 5. Okay, and then if I execute, so I'll get top 5 values. Okay. Now, next use case is basically if I want to track. So basically, you can create these. I mean, you can use these data analysis for. So basically, I am having this orders measure. So on that orders measure, I can create these KPIs, or I can use these analysis for orders and with respect to customers. Okay. Now, if I want now let's look at a different use case. So if I want to track payments, okay, now the first example would be like I want to find out a list of all orders with payment status. If I want to do that, so basically I have to use so first, like, list of all orders with payment status. So I will be using orders, okay, and then I'll be using the payments table. Okay, so now let's do that. So I'll be using select. Okay, now in this particular example, I will not be using payments columns in my select clause, or within my select clause. I'll not be using payments column, but still I can use it in the join, and still I can use it in the grouping and all. Okay, so but yeah, in this scenario, we will not be doing grouping, but I'll show you, like, without even using it in the select clause, I'll still be using it in the relationship or the joins. Okay. Now, so I'll be using select order ID, okay, and from order dot sales, okay. Now I'll be using okay. Now here basically what I'll do, I will be adding. So here we will be looking at a, case statement, okay. Let's take a look at the case statement. So basically, if I want, I mean, if there is a scenario where I want multiple cases, like for example, if a payment is not null, then paid, it says paid, else it says pending. Okay, so if I want to add a case statement, I can do that. Okay, now to add a case statement, I'll use some indentation here. Okay, so I'll use case when p dot payment ID is not null, then paid. Okay, else I would say pending. Okay, and then in the case statement, I can keep adding multiple conditions. Okay, I can add multiple when. So I can keep adding multiple when, and then at the end we have to use and then we have to provide an alias name. Okay, as payment payment status. Okay. Okay. Now, next we will create the relationship. So from orders O. Now, uh, from orders O. So now this time we will be creating a left join. So we don't need to create an inner join. So basically, I need all the values. Okay. So that's why I'll be creating left join. So basically, I need all the values from orders table, and the matching values. If it exists, then it will come in. Otherwise, we will get a null. Okay. I'll be using left. Okay. Left join. payment name is P. So on P dot ID, sorry, on order ID, right? Dot ID, and then I'll create relationship with payments. So P dot. So what I have is basically payment ID. Based on payment underscore ID, right? Payment underscore ID. So yeah, now it looks good. Okay, yeah. So my query is ready. So now if I go ahead and execute, the relationship that I created is not able to identify. So what we will do, rather than using payment ID, we will use, let's see what are the fields that we have. Order ID. We'll use this order ID. The relationship. Okay. Okay. Yeah. So now we got it. Okay. So what we did, so basically I'm trying to connect. So order ID from orders table is basically my primary key, and order underscore ID from payments table is the foreign key. So basically I'm trying to create the relationship. Earlier when I used payment ID, so payment ID doesn't have any common values with order ID because payment ID is for tracking payments. So it has a separate ID. So basically if I want to tag between two tables, I have to use a common field or I have to use a column which has common values. So order ID basically is the column which is used to track whether a certain order has been, a payment has been made against a certain order. So that's why we have to use order ID. Okay. So whenever you're working on any data engineering task or any data analysis, understanding the business is also very important. Not just, I mean, having knowledge about the queries or different techniques in SQL is important, but on top of everything, having knowledge of the data, the background of the data, or the background of the project, becoming a um, expert in the business or understanding the data is more important. So that helps you a lot. Okay, so here I'll fix it a bit. So basically, this total sales, I will name it as total sales. I'll execute it again. Okay. Now, next we will see if I want to find out total sales for paid orders. Okay, if I want to find out total sales for paid orders, I can also do that. I'll create the relationships. Okay, now it's simple. So basically, if I just create select. Sorry. Okay, I just find total sales, but if I do total sales, so basically I will get, so, let me show you what a left join will do. So if I'm doing a total sales, so basically I'll get some of the values will be null. I mean, I'll get only those values which are getting total sales. Okay. Now this is the left joint. So I will get everything. But if I want only the total sales where, the orders have been, I mean, for the paid orders, so I will have to use an inner join so that, only the common fields between the two will come in, and the returned values or, sorry, not returned value, only the paid values will appear. Okay. So I'll use inner join and then execute. Okay, so now what we are getting, we are just getting the paid values. Okay, because if I'm having a certain record in the payments table, it means it has been paid. So if a value exists both in orders table and payments table, only then we can make sure, yes, the order is complete and payment has been completed. So if I create a inner join, which will give me common values between the two tables, I will be able to extract, or I'll be getting only those orders which are having which have been completed with a payment. Okay. Now, the next scenario is basically if I want to do orders paid in a specific date range. Okay, I can also do that. So let me show you. So I have sales. Now I'll bring in order ID o.id. Okay, so this is my order ID from orders. Now I will create join. So if and remember one thing, if I'm just using join, okay, if I'm just using join, it means I'm creating an inner join. Okay, and if I'm not mentioning like anything, any particular join or anything, it means I'm creating an inner join. Okay. Now, if I can use from orders join payment, then I create the relationship. Now, if I want to add filters, so basically our objective in this scenario is we have to get orders paid in a specific date range. So I have to add a where clause. Okay, where p dot payment date. Okay, between a particular date range. Okay, I'll provide like a date range. Um, okay, okay. So now if I go ahead and execute, okay, so there is no value in this particular date range, so that's why we are getting this. So let me see if I'm having some values in a different date range. Okay, so between this particular date range, so these are the values. Okay, so this way I can get orders paid in a specific date range. Okay, now next, if I want to find out what's the average payment turnaround per customer. Okay, so in an average, each customer how much they are paying, each customer how much they are paying, I can also do that. Okay, now for this I will use customer ID. Orders dot customer ID, and then I'll be using, okay, I'll be using the difference between two date ranges. Okay, so I'll use date diff function, okay, between two date ranges. So date diff, so p dot payment date and o dot order date. Okay. Now, I'll remove this where clause. Okay. So this date diff, that are three arguments. Uh, Payment date and order date. to provide interval as well. Okay, because I want to find out days. So yeah, so this is what I want to find out. So now if I execute, okay, so I'm getting for every customer, so I'm getting the difference between payment date and order date. Most probably the payment date and order date could be like same, because there are some data that or there are some cases where the payment and orders, they were generated in the same day, or in most of the cases. So I'm getting a zero value. But in case if you have different value, you can do that. So on top of it, if I want to add an average, so I can add average. Okay, and then I want to provide uh, uh, an alias name, so I'll call it as average days. Okay, and that's it. So then I want to also uh, since I've done an aggregation, average is an aggregation, I would like to do a group by. Okay, so I can use a group by o dot customer ID. Okay, so now if I go ahead and execute, so I'll get for all the customers what is the average. Since in all the cases payment date and order date is exactly the same, so that's why we are not getting any values other than zero. But yes, if you find a difference between payment date and order date for a different data set, of course, then we will be definitely getting uh, the average days, okay, using this approach. Okay, now I want to find out in the next case, I want to find out like what are the unpaid orders by customers. Okay, so if there are, I mean, there will be definitely some unpaid customers, right? So if I want to find out which are the unpaid orders by customers, okay, so to do that, again I'll be using the same relationship, but the type of join I'll be using this time will be a left join. Okay, now so I'll be using customer ID, and then I'll be using the count of uh, uh, IDs. Count of ID, and from orders. Okay, now I want to add another filter here. So basically, whenever, I mean, I want to find out, see, try to understand what is our main problem. I mean, what is our main use case. So I want to find out unpaid customers. So for all the unpaid customers, there will be no value, or there will be no records in the payment table. Okay, so when I'm creating a left join between orders and payments, so basically for the IDs where in orders where which will not exist in payments will get a null value, right? Because it's a left join. So I have to identify, or I have to extract the null value. So to do that, so we will be using a where clause where p dot payment ID is basically null. Okay. So now if I go ahead and execute, so there is, what I understand, so there is no orders which have not been paid. So all the orders have been, I mean, a payment, there is a payment for all the orders. So that's why we are getting we are not getting any records. Okay. So this is a typical example where, you may get a null table or without any records, but yeah, this is the approach. Okay. Now, in the next scenario, basically we will uh, okay, yeah. So in the next scenario, we will. I mean, these are some of the use cases, some of the scenarios. Next, we will see like if there is a table. Okay. So next we'll discuss about views. So what are views exactly? Okay. Um, so like if you need a table which you have to keep reusing it, okay, so in that particular scenario you can create a view. So basically if we go by the definition, so what is a view? So view is basically a virtual table based on the result set of an SQL query. It does not store data physically, but provides a way to look at data from one or more tables. Okay. And then views are basically complex queries which you don't want to keep running every time. And this also enhances security by restricting columns and provide data abstraction. Okay. And views are also executed by running a select statement in the view name. Okay. Now to create a view, let me show you the syntax. So let's take a look at the query first. So this is the query. Select o dot id name and sales. Okay. Now then I want to join customers see on customer ID and dot ID. Okay, this is the table that we have. If I'm executing this, I'm getting the output. Okay, but I can make sure. Yeah. So this is the table that I have. So if I'm executing it, I'm getting getting the output. But I want to keep using this table multiple times. So day in and day out, I'll be using this particular table with this kind of relationship, or it could be even complexer query than this. Okay. So I don't have to keep writing the query, or I don't have to keep copying the query every time. So I can create a view table. Okay. Now create a view table. Second. Okay. So this is the syntax. So if this is the query, then I can go ahead and create view customer orders as then the query. Okay. And then if I go ahead customer, or I'll copy the view name, and then if I go ahead and execute, it's selected, then that's why. Okay, so now the query is complete. So now if I just comment it out, star, slash star and star slash. So this is the way of commenting it out a particular section. So for at start, I'll give slash star, and at the end, I'll give star slash. So basically, anything between that will be commented out, okay, or it will not be executed. So now, if I want to execute something, select star from um, select star from customer orders, yes, and execute. So you see, now we're getting the output. So this is an example of a view. Okay. Now, so basically, no matter like whatever queries you are creating, you can always create views. So rather than every time running a query, so this view will act as a normal table, which you can use query. You can filter depending. Like if I want to add a where clause, where id is equal to 1. Okay, this is how basically we can use, just like regular tables, we can use this customer orders table, which is basically a view. Okay, so that's it, guys, for this session. Thank you so much for joining.